two laws of probability. The following two laws give the probabilities of unions and intersection of events. There are two theorems. One, the multiplicative law of probability. Next, the additive law of probability. First, let me talk about the multiplicative law of probability. The probability of the intersection of two events A and B is probability of the intersection A and B equal probability of A times probability of B given A, or probability of B times probability of A given B. If A and B are independent, you know this already, but let me write down probability of A and B equal probability of A times probability of B. This is true if A and B are independent. So let me show you this probability of B given A equal probability of B and A divided by probability of A. Then you multiply both sides by the probability of A. Then we have probability of B and A equal probability of A times probability of B given A. So this is the proof of this part. And next one you can have by considering probability of A given B. This equal probability of A intersection B divided by probability of B. Then multiply both sides by probability of B. Then you can have this one. Next, the additive law of probability. The probability of the union of two events A and B is probability of A union B equal probability of A plus probability of B minus probability of A intersection B. Then if A and B are mutually exclusive events, then what is the probability of A intersection B? If A and B are mutually exclusive, then probability of A and B equals 0. Then we can write probability of A union B equal probability of A plus probability of B. This is true if A and B are mutually exclusive. Now let me consider this. Find probability A union B union C. Okay, so probability A union B union C, I consider this probability of A and union, I consider B union C as another set. So we have two sets here, A and B union C. So then we can apply the additive law of probability, this one to this. So we can write probability of A plus probability of B union C minus probability of A intersection B union C. Now you see here probability of A, I leave it, but probability of B union C. Again we can apply the additive law of probability for probability of B union C. So let me apply that law. Probability of B plus probability of C minus probability of B intersection C. Right, then we have this part minus probability of A intersection B union C. So let me use this so we can apply this here. A intersection B union A intersection C. So we have again two sets. One is A intersection B union and other one is A intersection C. So there are two sets, so we can apply again the additive law of probability for this part. Let me show you probability of A plus probability of B plus probability of C minus probability of B intersection C minus, yes, let me apply the additive law. Probability of A intersection B plus probability of A intersection C minus probability of A intersection B, then intersection again A intersection C. So then we can simplify this. Probability of A plus probability of B plus probability of C. Then I use this one here, probability of minus probability of B intersection C, then multiply minus probability of A intersection B minus probability of A intersection C and plus probability of, what is this one? A intersection B intersection A intersection C. That means probability of A intersection B intersection C. Next theorem, if A is an event, then we can write probability of A equal 1 minus probability of A complement.